Welcome back to our help videos on our 3B13 test, and we're picking up on this video with question number 6 on the second page. Which one of the following statements are true? Let's jump straight to letter E here. It says 1 gram of carbon-12 contains 6.022 times 10 to the 23rd. No. And this is really where the definition of a mole comes from. A mole is defined to be the number of atoms contained in 12 grams of carbon-12, not 1 gram. Why did they pick 12 grams of carbon-12? Well, first of all, why did they pick carbon-12? It is because carbon-12 is the atom that AMUs are based upon. One AMU is defined to be 1/12 the mass of the carbon-12 atom. So if carbon-12 atom was picked or selected for comparing a relative scale of masses of atoms to one another, they figured for a quantity on a mole, they would pick carbon-12 as well. Why did they pick 12 grams of carbon-12? It was so that the numbers on the periodic table would have a dual meaning. The decimal number on the periodic table, if we look back on these, this decimal number in each of these squares right here has a dual meaning. It is the average mass of the naturally occurring isotopes of that atom in AMUs. It is also the mass that is needed in order to have 1 mole, or 6.022 times 10 to the 23rd, and that mass would be in grams. Number 7. Which of the following is the correct hyphen notation? If you remember, hyphen notation is the notation where you write the element's name or symbol, hyphen, and then after the hyphen you write the mass number. But what they're wanting to know is what's the hyphen notation for an ion? And they're telling you it's an ion, and it has 46 neutrons, 36 electrons, and 34 protons. Well, what does the mass number depend on? Has nothing to do with electrons. The mass number is the number of particles in the nucleus. The electrons aren't in the nucleus. So all we need is this 34 right here, that's the number of protons, and this 46 right here, that's the number of neutrons. 34 and 46 adds up to 80. So we know the number should be hyphen 80. So we're looking for an answer that has a hyphen 80. Letter AB has a hyphen 80, and letter AC has a hyphen 80. But we need to use the number of protons to figure out what the element is. So we need to look on the periodic table to see which element has atomic number of 34, or number 34 written in the box, and Moseley told us that it's that number. It's that atomic number which can be used to identify the atoms. So looking on our periodic table, we find atomic number 34 identifies selenium. So our hyphen notation should be selenium hyphen, and then we write the mass number. And in this case, the mass number was 80. And that would be letter AC, selenium. Selenium 80. All right. Which of the following is the correct nuclear symbol notation? Nuclear symbol notation for a neutral or normal atom that has a mass number of 56 and has 26 electrons. Well, we know if it's a neutral or normal atom, we know that the number of electrons which are negative would have to equal the number of protons which are positive. So we're looking for something with an atomic number of 26. So down here on the lower thing, we need a 26 because in nuclear symbol format or nuclear symbol notation, the atomic number, the number of protons, goes in the lower left corner. On the periodic table, they can put that number anywhere, but nuclear symbol format, it goes down. And then we're looking for the answer that has a 56, because mass number is the one that goes up. So the one that has a 26 for the atomic number and a 56 for the mass number is letter D. Let's take a look at the periodic table to be sure that even makes sense. Yes, here's iron right there. It is iron that has an atomic number of 26. On this periodic table, they're writing the atomic number up there. They can write it anywhere they want. This is not nuclear symbol format. Nuclear symbol format has an atomic number and a mass number. This 5585 in iron square is not a mass number. A mass number is number of protons and neutrons in the nucleus. you can't have 0.85 of a proton or a neutron. That 5585 is the atomic mass. That is the weighted average of the naturally occurring isotopes of iron. Letter D. All right, 9 through 16 is matching. And we are trying to match these answers right here. And we're wanting to match those answers according to information in this nuclear symbol format. Once again, nuclear symbol format, that 85 is the mass number. That's where it has to go. The mass number is the total number of particles in the nucleus, protons and neutrons. Oh, first question, what is the mass number? It would be 85. That's what the number is. 85 is letter AE. How many neutrons does this atom have? Well, this number right here is protons plus neutrons. This number right here is the atomic number. That's where that goes in nuclear symbol format. Once again, periodic table, it can go anywhere. But in nuclear symbol format, it goes underneath the 85. So how many neutrons does it have? We take the mass number, which is protons and neutrons, minus the number of protons. Protons plus neutrons minus protons leaves us just neutrons. So 85 minus 37 is 48. That's letter E. What is the atomic number? Hey, that's the atomic number right there. By definition, that's where the atomic number goes. 37, letter B. And if you take a look, rubidium, the 37 on the periodic table's upper left. That's fine. It can go above the element. It can go upper right. It can go lower left. It can go underneath. It can go lower left. It can go on one side. It can go on the other. There is no prescribed method for where it has to go on the periodic table because we know the number that's not a decimal on the periodic table is the atomic number, and the whole table is arranged, thanks to Moseley, by that number increasing. So what's the atomic number? It's right there. It's 37. How many electrons would a neutral atom have, or normal atom? Well, this is protons. Protons are positive. The protons would have to equal the negative electrons for it to be neutral. So 37 would have to equal 37. So the electrons would have to be 37 again. How many nucleons does it have? Nucleons, again, are any particle in the nucleus. Protons plus neutrons. There's our protons plus neutrons. 85 again is our protons plus our neutrons. Letter AE. How many protons does this thing have? Well, that's the same question as 11. This 37 is the atomic number. The atomic number by definition is the number of protons, 37. How many electrons would a 1 plus ion of this have? Well, we learned in question 12 that there's 37 electrons. When it's a positive ion, what do we know? If it's a positive ion, it had to have lost an electron. Why? A positive ion has to have more protons than electrons. So if it has 37 protons and it starts with 37 electrons, you would have to have one more proton than electron for it to be positive. So 37 is one more than what? The answer is 36. In other words, it lost an electron. It now has 36 electrons versus 37 protons. 36 is one less than that. Answer A, 36. And it would make great sense that rubidium, atomic number 37, would want to lose an electron. Why is that? Well, we take a look at rubidium right here. It's number 37. If it loses an electron, it ends up with 36. It ends up with the same number as krypton. Krypton is a noble gas. The noble gases are already stable. They're chemically stable. They have a filled outer octet. So when rubidium loses one, it's left with a stable, full outer octet. How many did rubidium want to lose? 1. Now we're looking at the periodic table of ions. Right here we see rubidium number 37. And in that square it shows us that it wants to be plus. Sometimes they write 1 plus. Sometimes they just write a plus. They mean the same thing. If rubidium loses one, it ends up like the same number of electrons as krypton. It doesn't become krypton. You would have to lose a proton to become krypton. But by losing an electron, it becomes plus 1. And Roman family 1 is characterized as the family that loses 1 electron. All right. That takes care of question number 15. Number 16, both the nuclide and isotope to this atom would have what atomic number? Isotopes are same element, but not identical, if you remember. They're the ones that are like twins, but not identical twins. They have to have the same atomic number or they wouldn't be the same element. In other words, they have to have the same number of protons, but they wouldn't be the same element if they didn't have the same number of protons. But they must have a different number of neutrons, which gives them a different mass number. Nucleides have to be the same exact atom, so they have to have the same exact number of protons as do the isotopes. But nucleides are different than isotopes because they also have the same mass number. In other words, a nucleide's identical twins, an isotope are not identical twins. So yes, nucleides and isotopes have to have the same atomic number. And what would that atomic number be? It has to be the same as rubidium's because they are talking about nucleides are same atoms of as the element we're talking about. In this case, it's rubidium. They would need a 37. This will conclude our video on page 2 of the test. The next video will pick up with page 3.